Welcome to the future.
Welcome to the Muxall Open Internet of Things video blog. I am your host, Michael Crane. In today's video, we're going to do the initial power-up of our BBQ Controller model RPTC-Q version 1 Main PCB we assembled in video number 26. However, when we power up the High Voltage PCB, which has our Meanwell 120 volt to 5 volt AC to DC converter on it, nothing happens. So we have to troubleshoot and see if we can repair our main PCB. And I need to warn you, there is a bit of foul language in this video as I start uncovering the problems. So let's get started, okay? So we're going to go ahead and fire up the main PCB, and really, I guess the button PCB at the same time, okay? And I've already got the mains AC plugged in. This is a Molex connector for the mains for the BBQ controller, as I showed you in the last video. Start powering up the high voltage board. It's right now, the switch is in the off position. And the reason why I have it in this odd angle, the only lights, I didn't add any LEDs on this board that shows that anything's powered up, which I might just actually fix that in the next rev, because we definitely are going to have a different rev. We need to fix the footprint on this for one thing, right? But there are LEDs on the ESP32 board, so we can kind of see that from underneath here. I'm going to keep it zoomed in, or I'll zoom it in when I go to turn it on. We know the main high voltage board works from the last video. We know we're getting 5 volts, or we're getting 5 volts to the female header right here, and so the 5 volts should get transferred down to the main PCB and also down to the button PCB. All right, so I'm going to go ahead and plug her in, and I'm not going to use the Variac this time because I don't think we're going to have any problems with the high voltage board. And so here we go. Okay, I'm going to go ahead and flip the switch, and that looks pretty dark. Okay, let me get my voltmeter out. Yeah, this is where an LED would be kind of nice, right? I check the 5 volts on top here. Set this up right here. I got on DC. I'll try to do this where I'm not sticking my hands in front of the camera, hopefully. I know, I apologize. My hand is always in the way. This is really hard to do. Oops. Okay, so we got 5 volts. Oops. I can stay on it. Okay, so we know we got 5 volts coming out of our AC to DC converter, and it's going to these pins, so it should show up down here. Yep, so we've got 5 volts going to the PCB. We know the high voltage board works, so what I'm going to do, I think, is I'm going to make a 5 volt power brick to feed directly into the main PCB so we can take a look at it and see why this isn't powering up. And I can't do that with the high voltage board covering it up, so I'll be back. Okay, so I have the power supply out, set at 5 volts. I set it to 1 amp. I think that'll be enough to drive the Wi-Fi and everything in our board here, in our ESP32. If not, we can always turn it up. Let me get you zoomed in here. All right. So I'm going to go ahead and fire it up. Let me get the meter out. So I'm going to go ahead and turn it on. Wow. Well, that wasn't too good. I'll show you what happened. Turn it on, and it is drawing absolutely zero current. That, my friends, is not possible. So we've got something open somewhere. Okay, so let's see here. We should be getting... Okay, we got our 5 volts coming in. I'm going to connect to this ground right here. All right. Let's see here. See if I can get you guys zoomed in a little bit more so you can see what's going on. Okay, so I want to check the 5 volts going into the ESP32. Yep, we got 5 volts going into the ESP32. Let's see, do we have 3.3 volts coming out? Well, it should be 3.3 volts, not 5 volts. What is going on here? Okay, so I slept on this for a day and came back and thought I'd do some more testing. I am truly baffled why, if we go from the negative to the 5 volt, we're getting 5 volts, and if I go to the ground, we're getting 5 volts. I am just truly baffled. But then I thought, you know what? Let me just try going 5 volts here to ground here. Nothing. Deader than a doornail. So, something is not right, and it's starting to smell like a ground. I think what I'll do, I'm going to go ahead and power this thing off. I'm going to take this ground off, and this lead right here, put on ohms. And let's just check between, this ground and this ground. Yep, see? Let's check between the 5 volts and, yeah, see, the 5 volt rail is good. From this ground to this ground, we've got an open. That definitely will cause a problem. So now I have to try to figure out where the problem is. I'm going to go ahead and just flip it over, and we'll take a closer look at it, all right? Okay, so I went ahead and flipped it over, and this didn't take too long for debugging. This is flipped over, so here's our power in pin, okay? And here's our ground. And I don't know if you can see that or not, but that ground is not tied to the flood fill. So that definitely is a problem. That's not going to work at all. And I don't know if you can see it on camera. I'm going to go ahead and pull our button panel off. I'll have to take this knob off here. And I'm going to make sure, I'm going to see if we got the ground through to this too. I'll be back. Okay. So you can see right here, I don't know if you can see it in the camera or not. Let me see if I can get the angle right. Yeah, so you can see it. There's the ground going to, it's kind of a little ground plane going around these capacitive touch buttons right here. So I need to look on the bottom of this guy right here. It's this pin right there. Oh, I'm looking at the wrong side, aren't I? Oh, okay, well, I'm not going to be able to see it. So let's see, I'll just check and see. We need it from, is it this pin? Let's see, so we're like, yeah, so it's this pin right here. All right, so flip this over, it's going to be this pin, yeah. And it looks like it is not connected either. Okay. All right, so let's go take a look at the schematic. Maybe that'll shed some light on this. Okay, so I've pulled up the schematic for the remote programmable controller. We'll just call it the BBQ Controller main board. And if I look down here at the connectors, I see the 5 volts and no grounds. And if I come over here to the So this is coming from the high voltage PCB, right? So we have the 5-pin headers there. And this is for the button panel. And you can see the 5 volts, 3.3 volts, and no grounds. So I completely spaced out and forgot to run grounds between the boards. And it's not really grounds, it's the negative side. So it's the negative side of our 5-volt power supply, right? So, yeah, darn. And I know if I let me pull up the high voltage board. Yeah, so I definitely ran it. It doesn't really, I don't really show it going into a connector, do I? Yeah, so this doesn't have a, but I know it's going into a connector. Let's pull up the PCB real quick. Yeah, so here's the ground coming out and going to the pin. This is interesting. This is, this doesn't look right. Hold on for a second. What's happening here? Okay, so I'm showing pin 3 going to ground, pin 4 is 5 volts. So, let's see here. Oh, okay, so here's pin 3. Okay, going to ground. Pin 4 is plus 5 volts. Yeah, so so this evil bottom view footprint is struck again. So usually in these data sheets, you know, they give you the footprint of what it's going to look like on the PCB. They don't flip it around and invert it like the stupid bottom view that Meanwell has in their data sheet. I mean, this is the most idiotic piece of crap I have ever seen. I mean, because this thing is evil. This thing is bad, right? So, so what happened here? We've got, you can see the negatives on the top, positives on the bottom. Line in is on the top, neutral in is on the bottom, and that's pretty much the way I designed it. All right, let me see if I can get both of them up here. All right, so I've got, you know, so it's showing negative on this. I've got the ground, 5 volts, and then I have the neutral in right here on the bottom, and the line in on the top, right? If you look at the top of the of the Meanwell power supply, you can see that it's got the AC in neutral on the top, which is basically everything is flipped over from the stupid bottom view. Why didn't they just put exactly what's on the top of their power supply? I mean, geez. Meanwell, mean is right. This is mean. This is evil right here. No wonder I'm reading plus 5 volts everywhere. It's probably a good thing I screwed up and didn't connect the ground pin to the copper pore on the bottom of the PCB. It probably would have had a meltdown. I mean, geez, who knows, you know? I mean, I think I would have been able to tell, because I did ohm it out before I turned it on to make sure there wasn't any shorts. But I mean, this is just evil. Anyways, so I based my design off this stupid footprint or whatever this bottom view piece of crap is. So that's why I've got the ground at the top, 5 volts at the bottom. What's interesting, boy, talk about one error after another. So I didn't even realize that these were flipped, right? And flipping the AC side doesn't really matter, right? This is just going into a transformer probably. So this probably doesn't matter, you know, the flipping the neutral and the line inputs. But, you know, flipping this is bad. So anyway, this thing came with plus 5 volts at the top and the negative side on the bottom. And so I just I plugged in the plus 5 volts into the ground right here, which is the first pin. If you remember when I was testing it, remember the ground was on the outside and the 5 volts was, I'm sorry, the positive was on the outside and then the ground was in the middle. So this pin right here was the ground, or the negative side coming from coming from this mean well, and of course this thing wasn't even hooked up, and yeah, it's just one error after another. Okay, let's see if we can make heads or tails out of this complete mess. Okay, I'm going to go ahead and move the labels around so we can look at our PCB. Now, I guess I'd have to flip it in the footprint. I'm not going to do that. Let me just add another label in here real quick. We'll call this AC-N. So that's what this guy is. And this guy is really, so this is the line 5V0. Hopefully this will be good enough for now. All right. Okay, so we've got the neutral and the line. And like I said, I don't think this makes any difference, so I'm not too worried about that. It's just going through a transformer. But this right here, so we got the 5 volts going into pin 5. All right, and if we look at the schematic, so we've got pin 5. I actually have it connected to 5 volts. So is this error number 3? Jeez, what a mess. Anyway, you can see there's no ground. But I guess I had a double mistake. we just lucked out and through a comedy of errors, we got the 5 volt on the right pin. What a mess. Okay, so this is right actually. The 5 volts is right. Here, maybe if I move them here, it'll be better. There. Okay, and so pin 4 is going nowhere. According to the schematic, it's just X'd out, or not connected, and so it's not connected to the ground plane. So, in theory, all I have to do is connect this guy to ground, right? Well, I'm not going to update the schematic. I've got another schematic I'm working on, version 2. But anyway, I was going to connect this to ground so we could look at it, but just try to remember this is connected to ground, all right? So pin 4, so I come back to our PCB. That's actually right. So, all right, so what do we have to do? What mess do we have to do to fix it? I think all I have to do is on the main PCB let me see if I can pull that guy up. Okay, yeah, so I think all I have to do, so here's pin 4 is coming down. You can see it's not connected to the floodplain on the bottom. So I think all I have to do is scrape some of the solder mask off over this flood fill, and just put a little blob of solder on there, right? And while we're looking at this, let's go look at this guy. So yeah, so this is the 3.3 volts coming out of the ESP32, the DC to DC converter. You can see it goes over here to pin 1 on header J4. If we look at the bottom. Yeah, so here it is right here. So I guess pin 2 right here should be ground. It doesn't really matter where I put the ground, I guess, but oh, that's right. Well, we need to go look at the button PCB. I do believe pin 2 was ground. Okay, so pin 3 is the 3.3 volts coming in, even though it doesn't show it. It is. You can see right down here, this is VDD, so that's the 3.3 volts power input. This microchip capacitive touch sensor. And here's the ground right here. You can, I didn't even see it, but probably a bottom view would have been better. But you can see right here how it's tied to this kind of a flood fill area that I put around the buttons. But yeah, so this is the ground. So pin 1, and if we go back to, now we're looking, we need to make sure we're looking at this the right way. So, okay, so let's look at it from the top view. Okay, so the button PCB mounts on top of this guy right here. So we've got this right here is our, this pin 1 right here is our, should be connected to, yeah, this right here, right? The pin 3 up here. Man, I'm going to have to fix this. This is way too confusing. I'll just have to flip these connectors around so all the pin numbers line up. But anyway, yeah, but that's right. So let's say top goes to top, right? And then bottom should go to bottom, which is the ground. So, and pin 3 right here is not connected to anything. In fact, he looks like he's almost isolated. So yeah, getting the ground through that guy might be a tad tricky. Or maybe I just put a bodge wire from pin 3 all the way up here to pin 4. That would probably be the easiest. All right, so then we'd have ground going to the button panel and into the main board. All right. Okay. One other thing I wanted to look at is, this is for the button panel backlight, those LEDs that we installed. And if we look at the schematic real quick, you can see this connector J10 here, 5 volts, is on pin 1 and backlight is on pin 3. I was looking at this earlier, so let's go back and look at, okay, so here's our main PCB. Let's go down here. Let's forget the pin numbers for a second, because I think this is what screwed me up when I was doing this. So, okay, so here's a 5-volt rail, right? And he's on the top pin. Let's call him the top pin. It doesn't matter what side, he's on the top, right? And if we look at the button panel, the top pin is pin 3, not pin 1. So I think I've flipped one of them around. I don't know which one. The problem is pin 1 is a 5-volt rail here, and that's connecting to pin 3, which is going to the gate of this MOSFET underneath here, right? The Q10 MOSFET here, you can see it's going to the gate. So, yeah, so I've got this connector wrong. Let's see, and let's see if we can figure out which one. It doesn't really matter. I've got to fix it. But if this is the 5-volt rail and this is the backlight, then I probably just need to flip this one around if I'm looking at it right. Yeah, so the backlight's here and the 5-volt rail is down here, right? I don't know, maybe I should standardize it and put pin 1 at the top of all these connectors, or put it all at the bottom. Looks like all these, I have pin 1 at the bottom. Yeah, so I've got them just flipped every which way here. They're on the bottom here. Pin 1's on the top here. Who knows what I was thinking. Anyway, this is not going to work. It's going to send 5 volts to to the gate all the time. The reason why all this happened, just to kind of explain what happened, is when I originally designed this, I did the whole schematic in one file. Problem is DipTrace doesn't allow you to make 3 different PCBs out of one schematic. It has to be on one PCB. So then I split everything into 3 schematics and 3 PCBs, and then I added these connectors in there. I obviously didn't do my due diligence on verifying these connectors. And so it's coming back to haunt me. But this was not my fault, this stupid footprint that Meanwell had. But you get the point. So what I'm going to do, let's see, what can I do? So I can go ahead and put the bodges in get our ESP32 running. So all I'm going to do in this video is just tie the ground to the to the flood fill here. Type in 4 to the flood fill and see if we can power up our ESP32. I'll be back. Okay, I soldered, I just scraped a little bit of solder mask off the flood fill and just blobbed a piece of solder over. I'll take a picture of it and take a high-res picture of it and show you, instead of showing you on the camera, it'd be easier to see. But so right now I'm just going to have it set on ohms. I'm going to check the continuity. So this is our power pin. If I can do this and without covering up the camera. Okay, ready? Okay, so there's a power pin. Here's a ground pin. So 33.4K. All right. And I just moved this one over to the ground, so I don't see any shorts. It looks pretty good. Let me go get the ESP32. Well, let's try firing that guy up again, all right? Alrighty, got the power supply hooked back up. Let me see if we can flip this over. Maybe I should have done this before I turned the camera on. There we go. Looking to see if we can see any lights down there. Alright. Zoom in a little bit more. Okay. Maybe I should have left it zoomed out so we could see if anything smoked. Alright, I'm going to add some power. Woohoo! I don't know, can you see it? Oh yeah, so you can see it. We've got lights in there. One of the things I noticed is we've got a backlight. So I'm not exactly sure why we're getting a backlight. I'm going to go ahead and turn this off real quick. Okay, so I took off the ESP32. I'm going to go ahead and power the board back up. And yeah, it's not drawing hardly any current now. And I noticed that the backlight is not on. Oh, I stand corrected. The backlight is on. So let me turn this off. There we go. Yeah, this is probably not meant to be moved around so much, right? Well, that's interesting. So I turned the power back on, now the backlight's off. So yeah, I don't know what's gigging with that. I turn the power back off. I'll be back. Okay, so I turned the power back on and lo and behold, the backlight's on. And I think what I did is I just drug my fingers across. I must be toggling one of the FETs in there. That's kind of interesting, huh? I'll probably fry the thing doing that, but that's pretty interesting. I can just turn it on and off with my finger. How about that? Okay, so I just took this ESP board back over to my computer, plugged it in using a USB cable, and verified that it still boots and the Wi-Fi comes up and I can ping it. So what I'm going to do now is I'm going to go ahead and boot it up. Oh, and that red light doesn't do anything except, show solid red. So I didn't know if it was supposed to blink or something like that. I couldn't remember. Anyway, it just shows solid red, so I'm going to boot it up and see if the Wi-Fi comes up on our main board like this, all right? So I'm going to go ahead and turn this on and let it boot up. And while it's booting up, I'm going to come over here to OBS Studio, fire it up. Here's my command window, and let's see if we can ping that guy. Yes, we can. Excellent. So thumbs up. That actually works. Great. This is great. Making progress. Well, so here it is. I think I showed you already the where I put a blob of solder from the ground pin. Where are we? Oh, here it is, right here. From the ground pin to the copper fill ground plane, and I went ahead and added a bodge wire to it and run all the way over for the button panel. I just went ahead and threw some connectors on here. These pins were reversed and these pins were reversed, and this has nothing on it anyway. I think if we look at it like this, yeah, so you can see these are reversed. These are straight. The blue or purple's on the top, blue's on the bottom, but I think it's still reversed. I'd have to go look at the schematic. I really screwed this up, and of course this is reversed right here. But anyway, this kind of makes it easy for me to work on like this, because I can flip this. If I'm working on an LCD, I can flip it around and use the keypad. And if I'm looking at something down here, I can still use the keypad. So yeah, that actually worked out pretty good. I did verify I can plug my PC into this and power the whole board, which I was surprised. That worked out well. One last thing, I can also power the board through the power header right here. This is just a little adapter that I plugged a header pin in, and it just clamps down. These are kind of nice. I forget where I got these. Maybe Adafruit or something. I don't remember. Anyway, you can just plug in one of these AC wall warts, and it outputs 5 volts. I can just make sure I get the polarity right, plug it in like this, and power it up. This works pretty nice. But what's really nice is I can power this thing through my PC through this USB port. So that makes it really convenient, because I was kind of worried I was going to have to keep pulling this little ESP module off of here to upload software, but I don't have to. Don't forget, you can support the Muxall Open IoT channel by donation using a credit card and PayPal, or by purchasing products at the Muxall store. Details and links are in the description under this video. Well, that's it for this video. If you liked the video, give it a big thumbs up, that helps, and hit the subscribe button. That really helps. If you have any questions or comments, post them in the comments under this video. Thanks for watching, and I'll see you next time.